Hello everyone, I'm Adish. I'm here to discuss about the technical seminar topic Software Defined Network Based Management for Enhanced 5G Network Services. So here, let us first discuss about the software defined network. So what does a software defined network basically mean? Software defined network, also known as SDN, is the decoupling of network control logic for the devices performing the function, such as routers, which control the movement of information in the underlying network. SDN features controls the overlay above the network hardware. Technically speaking, the network control plane and the forward plane are separated from the data plane, enabling the organization to program network control directly. In traditional networking, each network device, such as routers, switches, and firewalls, has its own control plane, which means that the network's overall behavior is determined by the individual devices themselves. In SDN, the network's behavior is determined by the centralized controller. So, what is 5G? 5G is the fifth generation of a wireless network technology that is being deployed globally, which has faster speeds, lower latency, greater capacity, and improved coverage area. 5G networks are capable of delivering download speeds of up to 20 Gbps, which is 20 times faster than 4G networks. SDN can provide a centralized management approach that enables network administrators to monitor and configure the network from a single location. SDN in 5G networks is expected to enable greater flexibility, scalability, and agility, enabling network operators to meet the demands. So, coming to the SDN's quality of service. Quality of service is an important aspect of network management that ensures that certain types of traffic are prioritized over others based on the importance of criticality. Traffic classification in SDN can enable the classification of network traffic based on its type, source, destination, and other attributes. Dynamic resource allocation. SDN can enable the dynamic allocation of network resources based on real-time traffic condition. Network slicing. With 5G networks, SDN can enable the creation of virtual network slices. This can enable the prioritization of critical traffic and ensure that quality of service is maintained across the network. Real-time monitoring. SDN can enable real-time monitoring of network traffic and performance. Network management. In SDN, SDN network management offers many benefits such as centralization, programmability, virtualization, open standards, and advanced analytics and monitoring. These capabilities can help network administrators more easily manage their networks, automate tasks, and improve overall network performance and security. These are the literature survey which are being referred for. So coming to the challenges that has to be overcome and its prime importance. So multiple services. Here, multiple services can be provided using the SDN system. So how it is taken place is for multiple services, standardization is the task of providing vibrant, universal, user-centered, and data-rich wireless services to meet people's high expectations. The cost factor. 5G technology isn't capable with previous generations. This leads to building the groundwork for something new. Ultra low latency service. Any delay in mission critical apps could lead to unexpected outcomes. It is necessary to achieve a latency of less than 1 millisecond to fulfill medical apps such as remote surgery. Here, ultra-low level latency service refers to processing of high level of data at a minimum delay. So, coming to the security issues, security is one of the most significant variables of any wireless transmission system. A 5G network must guarantee safety and privacy for end customers. So, implementation. Implementation takes place in three ways. So, the SDN architecture provides higher flexibility, scalability, cost effectiveness, and energy efficiency in 5G mobile networks. There are usually different architectures for SDN control plane. They are centralized control plane architecture. So in centralized control plane architecture, the SDN concept provides more flexibility in network management due to separation between the control plane and the data plane, allowing handling the traffic network through software. As we can see in the diagram, there's a separate control plane and a data plane, which is allowing the handling of the network through the software. The SDN control plane is usually composed of a centralized unit called Software Defined Network Controller, which is the manager of the whole network. This architecture suffers from reliability, congestion, scalability, and performance degradation due to the large distance between the control plane and the data plane devices. So the next method is something better than the centralized control plane architecture. So this architecture is known as distributed control plane architecture. This control plane architecture was introduced to overcome the drawbacks of centralized control plane architecture. This architecture consists of using multiple distributed controllers together, also known as cluster-based architecture. One of the key benefits of this control plane architecture is the quick decision response due to the availability of many controllers in the network. But this network architecture sometimes suffers from unbalanced due to large amount of data. This control plane architecture is costly due to the usage of many controllers in the network. So going on to the next type of architecture is known as LCPD control plane architecture. LCPD, generally known as logically centralized physically distributed LCPD control management. The number of controllers used in a network relies on the network characteristics among user requirements. This makes the centralized controller suitable in the small scale network. While for a large-scale networks like 5G mobile networks, multiple domains have to be created and multiple controllers should be used. Main functions such as latency, load balancing, redundancy, connectivity, and survivability is improved. So the key benefits of this process is higher speeds than ever before can be expected. High speed is the biggest benefit of 5G connectivity. Data rates can exceed 10 Gbps in a 5G device. Energy saving due to the highest transfer speed. No more frustrating waiting to load a web page. This by turn will ensure low latency and low battery consumption. Efficient and effective. 5G will function better and more efficiently than other networks. It offers faster speeds, low latency, better quality, and bidirectional shaping of large bandwidth. So, coming to the result, it provides higher flexibility, scalability, cost effectiveness, and energy efficiency in 5G mobile networks, providing higher throughput and lower latency compared to other control plane architecture. The LCPD controller management architecture is suitable in the case of wireless network in general. This control plane architecture is one that can better enhance network performance. This control plane architecture is the one that possesses less latency and higher throughput compared to other implemented SDN controller management architectures. So coming to the result in the graph, we can see here the red line indicates the centralized control plane and the dotted blue lines indicates the distributed control plane, and The solid blue color indicates the LCPD control plane. So it shows the delay between the centralized control plane, distributed control plane, and the LCPD control plane. After implementing the process, the average delay is reduced in the LCPD control plane, whereas the distributed control plane and the centralized control plane have a minimal delay. So coming to the throughput, we can see, as said before, the centralized control plane is indicated by red and the LCPD control plane is indicated by the solid blue, and the dotted blue black lines are indicated distributed control plane. So here the average throughput in the LCPD control plane is higher than the centralized control plane and the distributed control plane. So this proves that the throughput is minimum in centralized architecture but higher in LCPD control plane architecture than in other scenarios, which makes this controller management architecture better than other networks improvement. Concluded that LCPD control plane architecture has the highest change rate in throughput, but at the same time, it is the control plane architecture which is the highest throughput values. From previous simulation results, we have proved that the LCPD controller management architecture is usually one with less delay, higher throughput, and hence better network performance than others. This control plane architecture is better than a distributed control plane architecture, as in this architecture, each switch is connected to only one controller. So the rise of the 5G and its main challenges can be overcome through this process. This cellular network consists of a large number of connected devices and therefore a large amount of data is generated. So to cope with this issue, we have applied SDN into the mobile network to improve communication efficiency and quality of service of running internet services. The LCPD controller management architecture into this cellular network to better enhance the network performance compared with the SDN control plane architectures. We concluded that the LCPD controller management with architecture is one with less latency and higher throughput. Thank you.